Mr McTaggart, and this is video 4 in the vector series for higher, and we are looking at dividing it in a given ratio. This would probably follow your collinearity questions. Okay, so here's the question. The point P divides AB in the ratio 2 to 3. We have to find the coordinate of P. So again, I always start with a little sketch. It's just a sketch. So we've got A to B, and it is being divided by the point P somehow, okay? And we're told it divides in the ratio 2 to 3. So what we do is we start by writing A to P, so obviously to the shared point, in the ratio of P to B. They've told us it's a ratio 2 to 3, so you write 2 to 3 directly underneath like you would in ratio back in S2. Then what we do is we do a wee thing called cross multiplication. So we times that by that and that by that, okay? So that gives us 3, oops-a-daisy, wrong colour pen. So that gives us 3A to P equals 2P to B. And then we do a wee bit of playing around and we rewrite A to P as P minus A. So we've got 3 bracket P minus A equals 2 bracket B minus P. Expand your bracket, 3P minus 3Q. Oh, that's not a Q, it's an A. I misread my own writing. 3A equals 2B minus 2P. Now, bear in mind we're trying to find P, so we're going to bring all the P's to the left and all the other stuff to the right. So that's going to become a plus 2P, so we're going to have 5P equals, minus 3 will become positive, so I'm going to just put it first. So 3A plus 2B. And then at this point, what we can do is we can start plugging in what our vectors were. So we know what 3A was. So A was 2, 0, 3. So we've got 3 times 2, 0, minus 3, plus 2 times 12, 10, 7. Let me create myself a wee bit more space. So we're left with a little equation, and then you've done all the hard work, just about. So 5P equals, let's times everything out. So we've got 6, 0, minus 9. Add 24, 20, 14. So 5P equals, 6 add 24 is 30, 0 add 20 is 20, and minus 9 plus 14 is 5. Notice they're all multiples of 5, so you can just divide by 5. A good tip that if they weren't divisible, you've messed up, they should be divisible nicely. And that will give us 6, 4, and 1. Now, one last tip is you wanted P as a coordinate, so you must make sure you write it as a coordinate. Do not leave it as a column vector, which is what they've got there. And this is not the only method out there to do this, but it's a method I was taught and it's a method that I really like and generally find people's like because there's a kind of pattern and consistency and rote learning to it. Okay, let's look at another one. This question is very similar to the last one, but this time we're told that it divides in the ratio C to 1. So we've got C to D shown in a picture this time, so let's put P randomly here, and it divides in this ratio 3 to 1. So what we've got is C to P in the ratio P to D in the ratio 3 to 1. Now this one's actually probably going to be easier than the last one. We're going to cross multiply. So we've just got one C to P, so let's just call it C to P equals 3P to D. Let's break that down. So we've got P minus C equals 3 bracket D minus P. I'm going to expand that bracket to 3D minus 3P. We're trying to find P again, so all the P's to one side becomes positive 4P, and the C will go over, I'm just going to put it at the front, C plus 3D. We're now good to plug in some numbers. So C was 3, negative 1 and 2, and we've got 3D, so we've got 3 of 7, 3 and 10. And then just make myself a wee bit more space. So 4 to P equals 3, negative 1, 2 still, plus 21, 9, 30, which gives us 3 plus 21 is 24, minus 1 plus 9 is 8, 2 plus 30 is 32. Now remember what I said is that these should all be multiples of 4. So if you then divide that by 4, it means that P as a coordinate would be each of these divided by 4. So P would be 6 to 8. As a coordinate, that would be 6 to 8 written left to right. Remember, you must write it as a coordinate at the end. Okay, so in this question, this could possibly be part of a collinearity question. Like in an exam, part A would say, prove that the points are collinear, and then it could say, find the ratio in which Q divides P and R for your part B. So we treat it like we would a collinear question to start with. So my straight line goes from P to Q to R. So first off, I'm going to find what P to Q is. And then I'm going to find what Q to R is. So just both parts of the line from start to middle to end. So P to Q would be broken down to be Q minus P. So we've got 4, 3, 6, take away, -6, -7 and 2. Watch all your double negatives here. This becomes 4 plus 6, which is 10. 3 plus 7, also 10. And 6 take away 2 is 4. If I do the same for Q to R, that will be R take away Q. So it will be 19, 18, 12. Take away 4, 3, 6. Which gives me, 19 take away 4 is 15. 18 take away 3 is 15 again. And 12 take away 6 is 6. So the vectors aren't identical, but they do look like they could be multiples of something. So what I'm going to do is, to take myself a bit more self-room, I'm going to take out a common factor in each of these vectors. So the first one is simply got a common factor of 2. So 2 bracket 5, 5, 2. The second one looks like it's a common factor of 3. So 3 bracket 5, 5, 2. So now you can see that they are collinear, okay? So they're both multiples of the same vector. But the bit about deciding the ratio in which Q divides it. So here was P, here was Q, and here was R. So P to Q was 2 of the same vector, and Q to R was 3 of the same vector. So Q divides PR in the ratio 2 to 3. And that's how I do it, in the ratio 2 to 3. That's us. I hope this has helped. Thanks for watching. Bye bye.